evaluate the limit. Limit x tends to 1, log of 1 minus x divided by cot of pi x. As x tends to 1, numerator tends to 0 because log 0 is, numerator tends to infinity. As x tends to 1, we have 1 minus x tending to 0 and log 0 remains undefined. As x tends to 1, we have denominator is tending to cot. So this is of the type infinity by infinity term. So we can apply L'Hopital rule. In L'Hopital rule, we just need to differentiate the numerator, and so does the denominator, and then compute the limit. In numerator, you have log of 1 minus x. In denominator, you have cot of pi x. Now, if you differentiate log of 1 minus x, then you will obtain 1 by 1 minus x. Derivative of 1 minus x is minus 1. Derivative of cot x is minus cosec square x. But you have pi x, so you need to differentiate pi x as well by chain rule. So pi. Limit x tends to 1 as it is. You are supposed to tend x towards 1. Oh. This quantity remains undefined, so does this. Minus 1 and minus will get cancelled, so you are left out with 1 by pi that you can write outside the limit. Limit x tends to 1 as it is. Let's rearrange. 1 by cosec square is sine square. 1 minus 1 got cancelled, so sine square pi x divided by 1 minus x. Oh, it is of the type 0 by 0 form because sine pi is 0. So as x tends to 1, this quantity will tend to sine square pi, and sine square pi will tend to 0. Denominator will also tend to 0. 1 by pi, that's just a constant that will not change the limit. Again, we apply L'Hopital rule. We differentiate the numerator. We differentiate the denominator. Limit x tends to 1 as it is. Equal to 1 by pi, limit x tends to 1 as it is. Derivative of sine square x is 2 sine x into cos x. So 2 sine pi x into cos pi x. Derivative of pi x is pi. What about denominator? If you differentiate 1 minus x, you will just get minus 1. Now, as x tends to 1, sin pi will tend to 0, cos pi will tend to minus 1, but everything is tending to 0 only, and we are done.